Thank you for joining this lesson. We're going to discuss floating and sinking, the Archimedes principle. State Archimedes principle. So the Archimedes principle states that when a body, you can say a body or an object, is wholly or partly immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. So the key parts of this law or the principle are wholly or partly, you can also say fully, immersed or submerged in a fluid. So we should talk of a fluid and not just a liquid. Some students make mistakes of even saying water. So we talk of a fluid, whether gas or a liquid. When a body is wholly or partly immersed, it experiences an upthrust equal to the weight of the fluid displaced. Part B, a solid of length 30 centimeters and cross-sectional area of 3 square centimeters and density 1.3 grams per cubic centimeter is completely immersed in a liquid of density 1.03 grams per cubic centimeter. Find part 1, the mass of the solid. It is good to know that mass of a solid is usually given by volume times density, rho. Now in this case, for us to get mass, then we need volume, then times density. The density is given for the solid as 1.3, but now instead of the volume, we have cross-sectional area and length. Therefore, cross-section area times length will give us volume. Then now we multiply by the density. This is going to be a cross-section area of 3, a length of 30, and a density of 1.3. So this is going to give us 3 multiplied by 30 multiplied by 1.3. This is giving me 117 grams mass. This can be converted to SI units, and the mass will be equivalent to 0.117 kilograms. That is when we divide by 1,000. Part 2, the weight of the solid in the liquid. So while in the liquid, the weight of this solid is going to be different, and we should know that this solid is going to experience an upthrust. According to the Archimedes principle, there is some upthrust which will be acting upwards on this liquid, and it will be acting such that the upthrust is equal to the weight of the fluid displaced. So we can look at upthrust, which will be weight of displaced fluid. Now, weight of displaced fluid, remember we are going to displace a volume equivalent to the volume of the solid going to be immersed. Therefore, using 3 as length and a cross-section area of 3 and a length of 30, this is the volume of the liquid that will get displaced. Now we multiply with density of the liquid, which is 1.03, for us to get mass of liquid displaced. So mass of liquid displaced shall be 3 by 30 multiplied by 1.03. This is giving us 92.7 grams. So because this is mass in grams, we can make it weight. To make it weight of the liquid displaced, now we're going to have 92.7 out of 1,000 to make it SI unit. And for us to convert mass to weight, we should multiply it with G. So this is going to be 0.927 newtons. So this is the upthrust which will be acting on this solid. Now with the upthrust, we can evaluate what we call the apparent weight, because we have the real weight in air. The real weight of solid is going to be mass times G. So it's going to be 0.117 times 10, giving us 1.17 newtons. This is the real weight when the solid is in air. But now that there is an upthrust acting on it, equivalent to 0.927, then the apparent weight, while this solid is inside the liquid, is going to be now real weight minus upthrust. A real weight of 1.17 minus an upthrust equivalent to 0.927. This is going to give us an apparent weight equivalent to, when I take 1.17 and I subtract 0.927, this is going to give me 0.243 newtons. So this is going to be the apparent weight of the solid in the liquid. Finally, we have a part 3, the apparent weight of the block if 3/4 of it is immersed. So if we immerse 3/4, then upthrust is going to change to 3/4 of a volume which is 3 times 30. So this will be the volume. Then we multiply now by the liquid's density, which is 1.03. This will give us the mass in grams of the liquid. So 3/4 times 3 times 30 times 1.03. So we're going to have 69.525 grams as the mass of liquid displaced in this case. So this mass of liquid now, which has been displaced, should be converted to weight, and it will be our new upthrust when 3/4 has been immersed. Therefore, we divide this by 1,000 and we multiply by 10. This is going to give us 0.6525 newtons. So this will be our new upthrust when 3/4 has been immersed. This means now there will be a new apparent weight. New apparent weight the new apparent weight is going to be, when we take the real weight 1.17 newtons and we subtract the new upthrust now 0.69525, this is going to be 1.17. We subtract, we're going to get 0.47475 newtons. So this is going to be the apparent weight in case only 3/4 of the solid is immersed. Thank you for following. Subscribe and share.